Hello guys, welcome once more to Class Online. My name is Dami, and in this edition we shall be looking at Jamb Physics 2011 question number 35 to 40, and we shall be dealing with very critical aspects of physics that will help you to understand a lot in physics. So at the end of this video, you will discover that you've learned quite a lot from those aspects of physics that most students find very difficult. Don't forget that if you learn something from this video, click on like button. We have a lot to share with you that will better help you understand and clarify a lot in physics to you. Now let's get to number 36. The correct expression for the potential at a point distance r from a charge q in an electric field is what? Now this question is super simple. It is just asking for the formula for electric field potential or electric field strength. Do you have any idea what that might be? Now that answer is simple. This is just the formula. It is V equals KQ over R, which is what? The K is the constant. It is the electricity. It is the electric field constant, and that is K modified into 4 pi E naught R. Okay, so that will give me Q divided by Q over 4 pi E naught R, and that is the answer. So the answer to that question is simply B, Q divided by 4 pi E naught R, and that's the formula for. This is from V equals K Q over R, but this K is the electric field constant, and that is 1 over 4 pi E naught, and that is what I have here. The 1 over brought the 4 pi E naught down, and that will become Q over 4 pi E naught R, and that is the answer to that question. That is just the formula for electric field strength, and that is what we were asked. Okay, so let's see. For electric field potential, and that is the answer to that question. Number 37 says 3 similar cells, each of EMF 2 volts and internal resistance 2 ohms, are connected in parallel. The total EMF and internal resistance are respectively what? The EMF, because they are in parallel, first of all, you must know that for any parallel connection, the voltage or the potential difference are actually, or the EMF is actually the same. For all parallel connection, you will not need to use the EMF formula. You just need to know that parallel connection, unlike series connection where the current is the same, the parallel connection has a characteristic for every electric connection. If it is parallel, the voltage is the same. That means the same voltage flow through them, through all the component parts of the cell. But if it is series, the same current flow through. So I have known that for series, current is constant. For parallel connection, voltage is constant, or the EMF is constant. So for parallel connection, share the same EMF, and that means that the EMF is automatically the same. It is 2 volts. But to calculate the resistance in parallel, like this way, okay, it doesn't have the same resistance. You will need to find the resistance this way: 1 over R equal 1 over 2 plus 1 over 2 plus 1 over 2. And that will give me 1 over R equals, the LCM of the 2 is 2. And that will give me 1 plus 1 plus 1. And that will give me 3 over 2. So my R will now become 2 over 3 ohms. And that becomes 0.7 ohms. So my resistance is 0.7 and my EMF is 2 volts. And that is the answer to the question. 2 volts and 0.7 ohms. D is the correct answer. And that is the way you find it. Please don't forget how I did that. I did the resistance as 1 over R equal 1 over 2 plus 1 over 2 plus 1 over 2. This is how to find resistance in parallel. Okay, but if it is the voltage, it is just the same, and that is the answer to that question. Now let's check out number 38. In ohm, electrical appliances and lamps are connected in parallel because why are they connected in parallel? Now this is also an electricity question asking about parallel. Now what is the advantage of parallel connection? Does it have less current will be used, less voltage will be used? Parallel connection does not eat up the wires. Series connection use high voltage. Why is it good to use parallel connection? Let's check it out. Now, for series connection, I did this: series connection versus parallel connection. Series connection has the same current, increasing voltage. That means series connection use high voltage through. That means this option D is correct because voltage in series use the same current, right? But it uses higher voltage. That means voltage has to be increased. It burns a lot of voltage. Then if one part of the series connection disconnects, everything goes off. That is common to series. If one part disconnects, everything goes off. But for parallel, it has the same voltage. I mean, parallel connection does not use high voltage, but it uses high current. And if one part is disconnected, others keep working, and that is the explanation. So the answer to that question is series connection. Parallel connection parallel connection use high current, but this one says less current, so it's wrong. So the only correct answer is that series connection use high voltage, and that is the answer. Series connection is not good. Parallel connection are used because it uses lower voltage, but series connection, it burns a lot of voltage, and that is why parallel connections are best. Now, number 39 says 2 resistors, 2 ohms and 10 ohms are arranged first in series and later in parallel to a 24-volt source. Now, the ratio of that's ROA. Now, that's not supposed to be ROA. That's supposed to be total power dissipated in the series and parallel arrangement, respectively, is what. Now, you can see that these are actually you need to find power, but you need to find power in series and in parallel. So now, how will I find power in series and parallel? The first thing I'll do is to combine these two things. Combine the two resistance in series and parallel. So the first thing I'll do is to, for series here and for parallel here. For series first, mix the resistances, and that will give me 5 plus 10, and that will give me 15 ohms, right? Now, don't forget that power is voltage squared divided by resistance, and that will give me, my voltage in the question is the same, that's 24 volts square divided by the total resistance in series, which is 5 ohm, and that will give me 576 divided by 15, and that will give me 38.4 watts. That is the power in series. Now, for parallel connection, if you are mixing resistances in parallel, you can't just add. You have to do 1 over R total equal 1 over 5 plus 1 over 10, and that will give me 1 over R total. The LCM of 10 and 5 is 10. 5 in 10 is 2 times 1 is 2. 10 in 10 is 1. 1 times 1 is 1. 2 plus 1 is 3 over 10. And my total resistance is 10 over 3, which is 3.3 ohms. Okay. Now, the power in parallel will therefore be normally V square over R. That becomes 24. That's my voltage here. Is 24. Still 24 square over the R is 3.3. And that will give me 576 divided by 3.3. And that will give me 174.5 as my power in parallel. Now, the ratio of the powers therefore will now become 38.4 is to 174.5. Now, divided by the smaller one, and that becomes 38.4 and 38.4. I'm dividing by the smaller ratio, okay? And that will give me 1 is to 5. And that is my answer. The answer is 1 is to 5. The answer should be 1 is to 5, not 1 is to 50. So there is no answer in the question. Now let's check out number 40. Which of the following will be applied when a metal Y is used to electroplate another metal X in electrolysis? Y is the cathode and S is the anode. Now the word electroplating is how you coat the metal Y is used to cover the metal X, right? So the metal Y is used to electroplate the metal X. Now have you ever seen a spoon before? I'm sure you have spoon at home. Now, you can paint things by rubbing paint on it, but you can also paint things electrically, and that process of painting things electrically is called electroplating. By running electricity through that thing and connecting that electricity to a particular metal that will bring the color of that metal into the other material, and that is a very permanent way of painting things, because once that thing is painted, it will last for so long. Because it was not painted by hand, it was painted by electrolysis or by electricity. And that is it. Now, the metal Y is used to electroplate a metal X, right? Now, what happens there? And this is what happens. Now, this is my metal. This is my Y. Okay, this is my copper plate here. It will electroplate this spoon here. Okay, so the current will flow from here and flow this way and flow through this spoon. And so the color of this metal, of this one, will come on this one. Okay, so what will happen is that the Y is now the anode, because the Y, of course, you know, this side is the anode side and this side is the cathode side. So during electroplating, it will flow from here and rub on this one and go around and keep flowing from here to this one and keep flowing around and around and around until the spoon has the same color with this material. So Y, which is used to electroplate is at the anode side and this spoon is at the cathode side, and that's why B is correct. Y is the anode and C is the cathode. Y is the anode and C is the cathode, and I think that is the answer. Y is the anode and C is the cathode. Although we don't have that in the option here, we have Y as the anode. That's true, but here we don't have Y as the anode here, so all these ones are wrong. So Y is the anode, and it happens at very high current, and that is also true. So the answer is Y is the anode. If they have said Y is the anode and X is the cathode, that is correct. Okay, they never said that Y is the anode. Okay, all the options are all wrong. Y is the anode is not in any of them. So Y is the anode is correct, and S is the cathode, and it happens at high current is super correct, and that is the answer to that question. And that brings us to the end of this edition. Don't forget that if you learn something from this series and you want to get more content that will better help you understand things, click on like button. We have a lot to share with you that will explain a lot to you. Until we see you again, guys, take care of yourself and bye for now.